So for today's lesson, the main learning objective is, given 2 points, we want to write an exponential function whose graph passes through those 2 points. So we're going to start off with the easier of the examples. So on your separate piece of paper, because you'll definitely need more space than is provided for you, here is example A. And you're going to understand, after doing the first 4 problems, why the first 3 are significantly easier. So the basic form for an exponential equation is given. You choose one of the 2, and really it doesn't matter which ones you use. You could use the first order pair or the second first. I will tell you that if they give you an ordered pair that is actually the y-intercept, remember y-intercept has a 0 in the x part and some number in the y. If they give you this, you're going to want to use that point first. It'll make your life easier. So I'm going to substitute a 3 in for y and a 0 in for x. One of the biggest misconceptions of students coming into Algebra 2 is they think that any number raised to the 0 is 0. But in fact, a number raised to the 0 power actually is 1. We're going to solve for A, and we're almost half done with the problem. Now I'm going to go back to this general function, and where I see an A, I'm going to substitute in 3. And I still have an ordered pair that I haven't used. So in the y, I'm going to substitute in 6 and -1 for the x. Let's isolate the b. There's more than one way to solve this. Just know that you can still follow math rules. There's more than one way to solve. I always try to go with whatever is the fastest or the easiest. So you're going to ask yourself, remember, whatever you do to one side, you must do the same to the other side to keep the equation balanced. What could I raise this to so that when I multiply, I end up with a 1? Because in our mind, they cancel out, but in reality, really, they turn into 1s. And so to get that number, you're going to take whatever this value is, and you're going to take the reciprocal. So -1 over 1, reciprocal actually becomes 1 over -1. We do that because the negatives cancel, the 1s cancel, and remember, even though we say it cancels, really what number does it turn into? It simplifies to a 1. So this is 2 to the -1 power, and that says 2 isn't happy being on top, so it's going to go to the bottom, and now it's happy. Once you have an A answer and a B answer, or a value for A and a value for B, we write our final answer is y equals A times B raised to the x. So this is an exponential function that passes through the given 2 values. Go on to part B. All right, so again, we can see that this is an example of a y-intercept because we have 0 for x and some value for y. We're not always going to have that, but when we do, let's take advantage. So in for the y is a -18, and in for the x is a 0. We know that b raised to 0 is really 1, and so a is -18. Now let's make a general statement. Look back to example A and look at example B. When you have one of the 2 ordered pairs, and one of the 2 ordered pairs is a y-intercept, what is the A value going to be? The 3. What is the B value going to be? -18. Do you have to go through all of this work and all of this work if you are given one of the values? No. So for instance, In the next problem, if I said it was 0, 5, I could simply write a is 5, and I move on to the next part. Okay, so now I'm going to write down y equals, and I'm going to replace a with negative 18. Then I'm going to substitute negative 2 in for the x and y. And we're going to isolate the b by dividing by negative 18. Two negatives make a positive. And 2 over 18 reduces to 1/9. Now currently we have an exponent of negative 2 over 1. So I could raise this to the reciprocal, which is negative 1/2. And by doing so, your negatives will cancel, your 2's and your 1's will cancel. Remember, really they cancel, that's what we think, but they turn into a 1. And now I'm going to apply this negative 1/2 to both values. Now, that's one way we could do it, but I taught you last unit that I prefer to take this negative value and keep it outside and only apply the 1/2 first. Remember that a number raised to the 1/2 is really like taking the square root. The square root of 1 is 1, the square root of 9 is 3. Now when you apply the negative 1, this says the 1 isn't happy being on top, so it goes to the bottom. The 3 isn't happy on being on the bottom, it goes to the top. And we can see that b reduces to a value of 3. We have an a value and a b value, and your final answer is y equals negative 18 times 3 raised to the x power. One through 5, your level of understanding. We're not done. We have 3 left to go. 1 through 5. Most of us are 3s, a couple 4s out there. Okay, we're going to flip to the back. Or my back. You probably still have space in the front. And we're going to look at option C here. Remember, not all problems, which we'll see in option D and E, not all problems will come with the y-intercept. But if they do, and we know it's a y-intercept, when the x value is 0 followed by some number. When it does happen this way, we can say, hey, we're done with a. A equals 3. Then we have y equals 3 times the quantity b raised to the x. I'm going to replace the x and y with a 2 and a 12. And we're going to isolate the b squared by first dividing by 3. And I want to show you 2 different ways, so I'm going to write this twice. 2 different ways that mean the exact same thing. They're just different forms. Some people are going to stick with the same pattern that we've been doing, and they're going to raise both sides to the 1/2 power. Totally fine. So b, remember this means square root of 4 is 2. Totally fine. We're going to come back to why it's not plus or minus in 1 second. Other people are going to see this, they're going to think back to freshman year or the beginning maybe of their junior year and go, okay, if I want to get rid of a square, I want to cancel it by doing the square root. b equals 2. Both acceptable procedures. Doesn't matter which one you use, okay? But what I do want to talk about is if you had to solve a problem and it was like this, and it was prior to doing exponentials, and I said solve this, you would take the square root and you'd say there should be 2 answers, plus or minus 4. Hopefully you remember that, right? 2 answers. So why, when we're used to seeing 2 answers, my fault, plus or minus 2. Why, when we're used to seeing 2 answers, why am I only writing 1 answer down? And the reason for that is think about an exponential equation. An exponential equation says that your b value needs to be always greater than, it needs to be a positive. It needs to be positive, and b will never be equal to 1. So for that reason, it will not be a negative 2. So that's why I'm only writing down the positive values of it instead of writing down both. Okay, let's go on to a harder problem, which is option D. If you did not hear me change the option, I need to correct your class notes. Option D should be positive 1, negative 6, and 3 and negative 54. Now this problem is different than the first three because one of the two ordered pairs is not the y-intercept. So I tell students, choose whatever ordered pair looks easier to work with. I'm going to start with the first one. And wherever I see an x and a y, I'm going to substitute in a 1 and a -6. And just like in the previous problems, our goal for the first part of this is to solve for a, or isolate the a. A is being multiplied by this quantity. Opposite of multiplying is dividing. And now I have a is equal to the quantity -6 over b to the first. Up to this point, a has been equal to just to some number. And we're going to bring it back to some number. But at this point, without knowing the value of b, we can't do that. Okay, then in the next step, we're going to rewrite it. And I'm going to plug in the a value here. And I'm going to substitute in the 3 for x and the -54 for y. Okay, let's go back to what you learned freshman year and we reviewed during your junior year. If you have b cubed on top and b to the first power on the bottom, because you have the exact same bases and you're dividing, we're going to subtract the exponents. 3 minus 1 is 2, so the b squared and the higher exponent was on top. Divide both by -6. -54 divided by -6 is a 9. And like I previously said, if I told you to solve this, you'd get an answer plus or minus 3. But because we know b represents a value in an exponential equation, it can only be greater than 0. So we're only going to get an answer here of 3. So I know a b value, that's good, but I don't quite know the a value yet. So I have to come back to a. b to the first, so 3 to the first is 3, and I'm going to be lazy and just go over the top of this and write a 3. -6 divided by 3 is -2. Now I know a and I know b. Y equals -2 times the quantity 3 to the x. Let's go on to option E. I'll give you a chance to write down the two ordered pairs. Neither one of the ordered pairs represents the y-intercept, so I can't simply say a is this value. I'm going to choose the easier of the two to begin with. Substitute in 2 for x and -8 for y. Now I need to isolate the a. A is being multiplied by this quantity, so I'm going to divide by the same quantity. And when I rewrite this problem, I'm going to substitute this quantity in for a, 4 for x, and -128 for y. Once again, I have b to the fourth over b squared. Same base and we're dividing, so we're going to subtract the exponents. 4 subtract 2 is 2. And b squared, the higher of the exponents, is on top. Can you please help me out? Please take -128 and divide it by 8. Thank you. And if I ask you to solve this, remember, your answer should be plus or minus 4, but because we know b is a value in an exponential equation, b has to be greater than 0, so we're only going to use the answer 4. Okay, I'm going to come back here. I know that 4 squared is 16, And I know that negative 8 divided by 16 reduces to negative 1/2. On a 1 through 5 scale, speed is not a factor. How well do you understand this concept, 1 through 5? Most of us are 3s, 4s, and 5s, okay? So now we're going to go back to reviewing what you've already done, but we want to gain a better understanding. So you can go actually stay on this piece of paper, and I'll tell you when we're going to go back to the sheet of paper. So here is a misunderstanding that I found out my previous students in earlier classes had. If I asked you to draw a picture, an example of exponential growth, it would look something like this. I'm going to abbreviate for time purposes. So exponential growth. As long as we haven't translated, it means we haven't shifted this thing up or down, this is what it looks like. Remember how this is the line, it's never going to cross this line, it's a horizontal asymptote? Okay? And exponential growth are going to rise as you go to the right. From left to right, they're going to rise up. Growth is very similar, but now from right to left, it's going to rise up. And again, as long as we haven't shifted or translated this function, this will be our horizontal asymptote on the x-axis. Those are two specific examples of exponential functions. Not all exponential functions are growth and decay. So if I said, draw me another picture that's exponential, but it's not growth or decay, it could look like this. Or it could look like this. Does everybody see that? And these cases, up here, what is your a value? Is it positive or negative? Well, your a represents your y-intercept. So is the a positive or negative? Is a positive or negative? But here, what are your a's? Negative, okay? So these are different. These are all examples, here's 4. These are all examples of exponential functions. But there's two specific types of exponential functions, growth and decay. Okay? So let's only focus right now for a little bit on exponential growth and decay. Okay, with your partner, I want you to identify, for the two pictures you see here, exponential growth and decay, I want you, and I'm just going to abbreviate exponential growth, exponential decay. I would like you to list on your paper what is the domain for both and what is the range for both. Okay? And I'm going to give you 30 seconds to do that with your current elbow partner. Begin. So you need to be talking to your partner. Okay, you ready? Ruben, can you help me out? Ruben, please tell me the domain for exponential growth. Okay, let me check. No limit how far it goes to the left, no limit how far it goes to the right. I agree. Jocelyn, can you please tell me the domain for exponential decay? Negative infinity to positive. Good. I will tell you with this next part, in the previous class, it took me 6 students to ask 6 students before somebody got it right. So I want you to go back to your partner. I don't care if you get a wrong answer, but I want you to really focus on this. What is the range for this? What is the range for this? I'm going to give you another 10 seconds. Go. No penalties for wrong answers, but I just want you to be real precise with your answers. Think about the limit, how low it goes and how high it goes. Okay, here we go. David, look at the range for exponential growth. Can you tell me what you believe the range is here? 0 to infinity. Did I write it like you wanted me to? Okay. Do you agree with that, Lally? Yeah. Okay. Cynthia, can you please tell me the range for exponential decay? Do you agree with that, Justin? Yeah. This is the one that students consistently got wrong. And because they were reading it in terms of going from left to right instead of going up or down. So in this function, how low does it go? It gets really, really close to 0, but it never touches it. Great job. Is there any limit how high it goes? No limit. So this is the correct answer, and that is difficult, I found out from the previous class for students. Hands up high if you were able to get this part right. So close to like 75% of us. Great job. Okay, you ready? Turn to your partner. What is the A value for both? You don't have to give me a value. Tell me what type of a number. A is here and A is here. A is positive. What about the B values for growth? What about the B values? Over here, tell your partner, what's the B value here? Not only is it positive, it has to be something else specific. B is greater than, anybody know? 1. And what about over here? B is between less than 1, greater than 0. All right. They both have a horizontal asymptote. And yes, it's at the x-axis, but at this point we're going to say it is the line y equals 0. That's assuming we haven't shifted this thing up or down. How many of you, thumbs up, to the side or down, feel pretty confident reviewing this? Like, yeah, I knew that. Some of this I had to review a little bit, but I knew pretty much all of that. Hands up. Okay. I'm going to go back to something you learned a couple days ago. And just look. This was either in your notes or your homework, and I apologize for not remembering. But they gave you this function, and they gave you this function. And can I have you plug them both in, do second plus 712 right now? And they asked you to compare the two. And if you recall from a couple days ago, we realized that these two functions reflect across the y-axis. These two reflect across the y-axis. Now, why is that so important? I want you to now look at number 2 in your notes. I know we've already done number 1, and we did it on a separate piece of paper because we needed more room. But now we're going to look here. Okay, we're going to make a couple predictions, and then we're going to check those. Please do second plus 712. Pay very close attention to this. Okay, you ready? Nothing right now on paper, only verbalizing with your partner. So your calculator's down. You've done second plus 712, calculator's down. Look at these 3 functions. I want you to make a prediction. Here are your predictions. Listen closely. Describe their domain, verbalizing. Describe their range. Describe their y-intercept. Those are the first 3 things I want you to do, and I want you to do in 20 seconds or less. Ready? Get set, go. Nothing on a calculator. 5 seconds remaining. Here's my goal for you. You'd be right on track with your understanding if this is what you're able to do. If you were able to look and go, greater than 1, greater than 1, greater than 1, I can see, by the way, what's this A value that's hiding here in each one? So if the A value that's hiding is 1, they all have a y-intercept of 0, 1. So they have the same y-intercept, and their B value is all greater than 1, which means they're exponential growth. So I'm looking like this. This is what it's going to look, something like this. It goes through 0, 1. But they're not going to have the exact same graph. They're going to be very similar. They're all going to have this shape, and they're going to go through the y-intercept, but how they change is how fast they go up. So making a prediction right now, yes, they have the same domain, negative infinity to positive. Yes, they have the same range, 0 to positive infinity. They all have the same y-intercept, 0 to 1. But yet their graphs are slightly different. So with your partner, I want you to describe, before we check, what do you think is going to be the difference of their graphs if they all have the same basic shape? 10 seconds, go. Okay, so I'm actually going to do this reverse. I'm going to have you write down the answer, and then we're going to look it on the graphing calculator, because I found out that the answer really confused students. They wrote down the answer, and they're like, I don't really understand what that means. So we're going to go backwards. We're going to write down the answer, and then we're going to look on our graphs to make sure we understand what the answer means. So please write this down for me. It's pretty wordy. Are you ready? Part A. In exponential growth functions, an increased growth rate, implies the function will rise faster from left to right. This is your growth rate. So what I am saying, and we're going to check it on a calculator, that if this number increases, it means it gets larger. What's going to happen is as I go from left to right, it's going to go up faster and faster and faster. After you cut through your y-intercept, it's going to go up faster from left to right. So let's check. You ready? We're going to do it kind of slow here. We're going to start by your first one. Please only plug in 2 to the x and hit graph. That's the basic, that's the first one they want us to try. And then go back and only plug in 6 to the x, and let's see if this applies. So it cuts through the same y-intercept, but do you see as we go from left to right, do you see how it increases faster? So the increased growth rate, which means I go from 2 to 6, means it's going up faster. Let's do one more. Let's now add in 18 to the x power. And we can see it even goes up faster. So let's make a little assumption. This is a 2, right? We know this number has to be, listen closely, we know this number has to be greater than 1 and not equal to 1. What if we did like 1.2 raised to the x? Where do you think, before I graph that, where do you think this is going to lie here on the graph? How will it compare to the other 3? Turn to your partner and say, what do you think is going to happen? Cuts through the exact same y-intercept, but it doesn't rise up as fast. Do you guys see that? Okay, so now here's the part that every class has gotten wrong, and I totally understand it. So I tried to first start with this concept. Okay, remember? They're going to reflect across the y-axis. So now let's look here. Do you see these 2 here, and these 2, and these 2? Okay. I want you to turn to your partner, and this is tough. I want you to think about it, articulate your thoughts. What do you think is happening with these functions? So as the growth rate, actually, do this real quick. Plug in 1 divided by 2. Just hit enter. 1 divided by 2. We get 0.5, right? Yeah. Now take 1 divided by 6. Did our growth rate just go up or down? Now take 1 divided by 18. Is it continuing to go down, or is it starting to go back up again? Okay, so as our growth rate in these exponential decay function goes down, what's going to happen to the graph? Turn to your partner. This is very difficult. Turn to your partner and describe what's happening to your graph. Go. So most students, in fact, almost every student I've called on in previous classes said that the higher rate, growth rate in an exponential decay function would mean it rises faster, right? Because that makes sense. That's what we just did with exponential growth. But now we're talking about decay. And remember, these have to be opposite. So if this represented, let me give you an example. If this represented 2 to the x, then x to the 1/2 would look like that, correct? And if this was 6 to the x, then this would have to be, because it reflects across the y-axis, this would have to be 1/6 raised to the x power. Does everybody see that? It's almost opposite of what you think. So ready? Please do me a favor. 2nd plus 7, 1, 2. Go to y equals. Start by, you have to use parentheses here. 1 divided by 2 raised to the x, and press graph. Okay, now go back to y equals. This time we'll use parentheses and we'll do 1 divided by 6 raised to the x. And you see how it's getting steeper? because it's reflecting across the x-axis. Okay, and we won't take time to do this last one, but if we did 1 to 18, we could predict it to be even more steep, right? Okay, so you're going to write down a statement here down below. You ready? For part B. How did our previous statement start? The one above it.
An exponential growth.
But this time, so we're going to say in exponential decay functions, a decreased growth rate implies the function will rise faster from right to left.